I happen to have a power MOSFET here. And here's the circuit I've got. I have a really nice bright, I think it's a 1 amp LED. Then I have a fairly small resistor, which is actually 4 resistors because I only have 1/4 watt resistors. So I needed to put 4 together. And then this goes into my MOSFET. So here's my drain, here's my source. I know it sounds wrong that current flows from drain to source. I have no idea why they named it that way. And here's my gate. Where is my gate? My gate is sticking up in the air. You can't see it, but back here I've just bent the gate up. Oops, let's move that up so you can see the whole thing. And if I walk over to this and, let's see, touch my 5-volt supply and touch the gate, it lights up. How did that happen? Well, I put current into the gate. How did I put current into the gate? I'm touching it with my left hand and holding it with my right. Anybody want to suggest how I put current into the gate? I'm a really crappy resistor. I'm about 10 megohms. But remember, it doesn't take much current to charge a capacitor. The capacitor, by the way, here is about 1 nanofarad, the input capacitor from gate to source. So I had to charge a 1 nanofarad capacitor through 10 megohms. Okay, you know, it's 10 to the minus 9th times 10 to the 7th. So it took, what, 100 milliseconds or so? No problem. Okay, I let go. Why is it still on? Yeah, I've charged up this capacitor. That's floating in air. No charge can get off. It stays on. It's on. No problem. I'm going to come over here and grab this ground wire here and touch my gate. Well, I discharged through another 10 megohms. Could be higher. Depends on sort of whether my hands are dry. I let go. This has now got 0 volts across it. There's no way for charge to get on here because this is just floating in air. It stays off. How much power does it take to keep this on or off? 0. No current's flowing. There's a voltage drop across here of, you know, about 5 volts when it's on, 0 volts when it's off. But if no current flowing, no power. That's why we like MOSFETs. They make great switches. And in fact, the on resistance of this power MOSFET is on the order of 20 milliohms. It's pretty small. So when you figure out the power that's being dissipated in a MOSFET, well, when it's off, how much power gets dissipated when no current flows? Not much. There's some leakage current, but it's in the very tiny amounts, nothing. When it's on, how much power is dissipated? 1 amp squared times 20 milliohms. Okay, well that's 20 milliwatts, and actually 20 milliohms a maximum. 20 milliwatts isn't much. So effectively, there's no power dissipated when it's on. You know, I mean, it's a couple milliwatts. There's no power dissipated when it's off, and it takes no power to keep on and off. Great switch. And that what we particularly like is the thing that turns this on and off doesn't have to be very powerful. Doesn't have to supply a lot of current. Here, the voltage source turning on or off this switch just has to supply enough current to charge the capacitor between the gate and the source.